Let's look at the question. The earliest moment when everyone becomes friends. So there are n peoples in a social group labeled from n to n-1. We are given a 2D array, logs, where it contains a lot of 1D array. For example, the logs at I contain 3 elements, which is timestamps I and xi and yi, which indicates that the person xi and the person yi will become friends at the timestamp I. Well, the friendship is symmetric. That means if A is a friend with B, then B is also friends with A. Also, if A is friends with B, then the person A is acquainted with a person B. Or if A is a friend of someone acquainted with B, then the person A is also acquainted with a person B. And finally, we should return the earliest time for which when every person becomes acquainted with every other person. And if there is no such earliest time, we just return -1. So let's look at the first example. We have 6 nodes, which is 0, 1, 2, 3, 4, 5. So they are strangers at the beginning. They don't know each other. So they are separate friendship group. And then we build a time coordinate. It is a calendar. All of the friend-made event happened in 2019. In the timestamp January 1st, the person 0 and 1 become friends. So they will form a friendship group. In the January 1st, the person 3 and 4 become friends, so they will form a friendship group. And in the January 7th, the person 2 and person 3 become friends. The person 2, 3, and 4 will form a friendship group. And in the February 11th, the person 1 and 5 become friends, so the person 0, 1, and 5 will form another friendship group. And in the February 24th, the person 2 and 4 become friends, but they are already in the friendship group, so nothing happened. And in the March 1st, the person 0 and 3 become friends, and now everyone 0, 1, 2, 3, 4, 5 is in the same friendship group, so now all of them is friends. This problem deals with the relationship or membership of entities as suggested by its name. A typical union-find data structure usually provides 2 interfaces, and another function is union A and B. If the groups are not of the same group already, then this function merges the 2 groups that the individual A and B respectively belong to. And to make the union A and B function more useful, one can return a Boolean value in the function to indicate that whether the merging actually happens or not. For example, when A and B and their respective groups are merged together, then the method union A and B will return true. And when A and B are already in the same group, then the method union A and B will return false. Thus, we don't need to merge them together. The first function is find A. This function returns the group that the individual A belongs to. This find method is used to determine the group that a given person belongs to, which is represented as a tree-like structure. So each group is represented by a group leader, and each person in the group points to its group leader. So this method is for finding the group leader for a given person. This method first checks whether the given person is the group leader of its own group. If it is, it will return the person's group index, and if not, it will recursively find the group leader by calling find on the group leader that the person points to, and updates the group leader for this person to the group leader that's found. So this update is called path compression, which improves the performance of find operation by flattening the tree structure of the groups so that the depth of the tree is reduced and most of the elements point directly to the group leader. So this makes the find operation faster and more efficient. Then it returns the group leader index. So with this method, the find operation has a time complexity which is O of alpha of n, where the alpha is the inverse Ackermann function. Well, it is extremely close to a constant, so it can be considered as O of 1 in practice. So now imagine that we already have the above union find data structure available. So then we can go over the problem again and try to come up with a solution by using this data structure. This lambda function sorts the list logs in ascending order. By the first element, each list contained within x at 0. It takes an element x and returns the first element of x, and the sort method which will modify the list logs in place. and sort it based on the values and return the key function. So in this case, the list will be sorted in ascending order by the first element of each list. We read through the logs in chronological orders, so in the problem description, since there is no mentioning whether the logs are ordered or not, we need to sort them first. So in order to ensure that we find the earliest moment, first of all, we just sort the events in a chronological order to sort the log items by the timestamps. And once the logs are sorted by time, we then iterate through them while we apply the union-find data structure. So for each log, we connect the two individuals that were involved in the log by applying the union A and B function. So each log adds more connections among the individuals. So if the two individuals are separate disjoint, then the connection is very useful. But if the two individuals are connected already via another individuals, then this connection is redundant. So initially, we treat every individual as a separate group. So the number of groups decreases along the very useful merging operation. So we merge the groups along that way. The moment when all the individuals are connected to each other is the moment when the number of groups is reduced to 1. At that time, it is the earliest moment when everyone becomes connected friends. But if there are still more than 1 group left, that means not everyone is connected, so we return -1. Let's create an instance of union-find class. We initialize it with an element. So in this case, the UF is initialized with n elements, and each element is initially in its own subset, which means that there are n disjoint subsets. So first, we create a variable group count, which will count how many groups we have. So first, we initialize it to n nodes, so every node have its own single separate group. And then we use a for loop for stamp friend A and friend B in logs list. So we iterate these 3 arguments in the log list. We use a union method to check after connected whether the friend A and friend B will form one component. So at that time, we can decrement the group count by 1. So we iteration the list of logs 1 by 1 and decrement the group count. And if it becomes 1, we just return the time stamps. So at that time, everyone becomes friend. So otherwise, after we run out of the iteration, it is still bigger than 1. That means there are more than 1 separate groups. Then at that time, we return -1, means not everyone becomes friends. This solution can be implemented in only few lines, so it's less difficult than the implementation of the union-find data structure.